And next, second type of data structure is non-linear data structure. Okay, non-linear data structure. So what is the difference between that? In first lecture, we covered array is one of the type of linear data structure. In unit 1 and unit 2, we perform operations on array. Array is a linear type of data structure, right? Okay. Next one is in third unit, there are two data structure we seen, that is stack, and again third data structure is linked list. Sorry, linked list is in fourth unit, stack, and then again one of the data structure type is queue. Okay, stack and queue. So these all data structure are in the form of linear data structure, means the all elements are in ordered manner, means one by one element is stored inside array, inside stack, inside linked list and queue. But what about linear data structure? We seen in last lecture that is three type data structure. It is non-linear type, means there is no predefined order, right? Predefined order is not there. Predefined order is not there. Again, this is the one type of data structure, example of non-linear data structure, and second example of non-linear data structure is graph. So our today's last topic of this unit is graph. Okay. So what is the meaning of graph? Graph is majorly used in various applications like geographical, okay, military base application. आता इथे यूज काय ग्राफचा? सपोज airline system wants to join some different cities, suppose Pune, Mumbai, Chennai, and then Nagpur. Okay, Pune to Mumbai, then Mumbai to Nagpur, then again Nagpur to Chennai, Chennai to Pune. ओके, अशा त्यांना फ्लाइट्स अरेंज करायच्या आहेत सिस्टीम. तर इथे मेजर पॅरामीटर्स इज डिस्टन्स, की प्रत्येक सिटी मधून डिस्टन्स किती आहे आणि त्याच्यासाठी रिसोर्स जो वापरणार आहोत आपण, काय असेल पेट्रोल डिझेल, जो काही त्या फ्लाईटला लागणार आहे रिसोर्स, मिनिमम रिसोर्स कमीत कमी लागेल आणि डिस्टन्स कमीत कमी लागेल अँड टाइम. अशा वेने आपण या सिटीज जॉईन करू शकतो इन एअरप्लेन सिस्टीम. सो दॅट्स वाय वी नीड ग्राफ डेटा स्ट्रक्चर टू एस्टॅब्लिश सच अ टाइप ऑफ प्रोजेक्ट. ओके, सो what is the meaning of graph? Graph means, graph is a non-linear data structure. Okay, non-linear data structure means what? Suppose this is my graph. म्यूट करा, रेकॉर्डिंग चालू आहे. ऋषिकेश सपकाळ. की कमी करत नाही. Okay, A, B, C, D. There are 4 vertices. Vertices means in tree we can call it as node, and in graph we can call it as vertices or vertex. Single is vertex, plural is vertices. Means here there are total 4 vertices, and this is the link between A and B. So in graph we can call it as edge. Okay. Then here A to C is connection and C to D link is there. Okay. So we can define graph. Graph is a collection of different vertices which are connected to each other. Okay. So we can define graph, that is we can call it as G. My graph G can be defined as it is a set of 2 elements. Means my graph G is a set of 2 elements, that is vertex and another one is edges. Okay, we can show it mathematically. So we can represent set by using curly bracket, and in curly bracket we can mention our elements of my set. So graph is a set of vertices and edges. Okay, means here V means what? V means vertices, and E means edges. Okay, V means vertices and E means edges. So now next, again V is a set of vertices, E is a set of edges. So we can represent my V set as V is a set of vertices. How many vertices are there? There are 4 vertices. So we can write down it as one by one, separated with comma, A, B, C and D. Okay, there are 4 vertices, A, B, C and D. And again, my graph contains second element, that is edges. So E is a set of edges. So first edge is A to B. So here I write down A, comma B inside round bracket, A, comma B. The next edge is A to C. So here A, comma C. Then C to D is my third edge. So here third edge is C to D. So this is the definition of my graph. Graph is a collection of vertices and edges. And again, we vertices contains set of vertex. Here there are 4 vertices, A, B, C, D, and there are 3 edges, A, B, A, C and C. Okay. You can represent your E set like this also. So here my E is, we can represent it as B to A, right, C to A and D to C. Meaning of both statements is similar. Okay, because there is no direction in my graph, right? So it is called as undirected graph. If there is no direction, so we can represent our edge A to B like this, A comma B, or we can represent same edge B to A. Meaning of these 2 statements is same. Okay, so definition of graph is completed. Next, edge. Edge means what? edge is used for to join two vertices of graph. Here vertices vertex A and vertex B are joined together by one link, because link is there. So this is my edge, right? AB. Then again A to C link is there, we can call it as edge. C to D link is there, we can call it as edge. So edge is a used for to join two vertices of graph. Then next terminology of graph is vertex. Vertex means what? It is a fundamental unit of my graph. It contains data of my graph. Or our graph is formed by using vertices and edges. Right? Without vertices, without edges, we cannot form a graph. If my graph contains single vertex, that is named as V, we can call it as again graph. So there is no need of edges, because there is one single vertex is available, we can call it as single graph also. So without vertex, we cannot form a graph. Right? Means graph is a fundamental unit of my structure which can form a graph. Okay? Then next is, there are two types of graphs. There are two types of graphs. Okay? Graph has two types. So here I divide my page into sections. First type is undirected graph. Undirected graph. And second type is directed graph. Directed graph. Okay. First type is undirected graph and second type is undirected graph. Okay. Okay. In undirected graph, the edges are unordered pairs. Means there is no direction from some vertex to another vertex. Again in directed graph, each edge is represented by a pair of ordered vertices. That is, an edge has a specific direction. Means what? Suppose my example of undirected graph is V1, V2, V3, V4. Okay, and these vertex are connected by edges. V1 to V2 edge is there. Okay, V1 to V3 edge is there. V2 to V3 edge, V3 to V4 edge is there. Okay, again my V4 and V1 is connected together. Okay, this is my example of undirected graph. There is no direction V1 to V2 or V2 to V1. We can call it as edge is V1 to V2. Again we can call it as V2 to V1 because there is no direction. If same graph is converted into directed graph, so we have to mention direction for edges. Like this, suppose here same graph, here I draw V1 vertex, V3, V4, V2, V1, V3, V2, V4. Okay, and edge is there. Here V1 to V2 edge is there. So direction specifies there is an edge from V1 to V2. So we can read it as V1, V2. But here in undirected graph, we can read it as edge V1, V2, right? Also we can read it as V2, comma V1. Okay. But in directed graph, we can read it as age is equal to V1 comma V2. We cannot read as opposite direction V2 comma V1. It is wrong because direction specifies there is a direction between V1 to V2. Means what? V1 sends data to V2. Okay. Here V1 to V2 age is there in undirected graph. Means V1 can send the data to V2 or V2 can send the data to V1 also. Both can send data to each other. But here there is single direction, so V1 can send the data to V2. We can read it as. So we can represent this age like this V1 comma V2. So V2 comma V1 is wrong. Okay. So next one is, now we can read it as V3 comma V1, right? Because from V3 to V1 age is there. So we can read it as V3 comma V1. Okay. Here age is there, V3 comma V4. So we can read it as V3 comma V4. This is my age. Again here age direction is from V4 to V1. So we can read it as V4 comma V1. Okay. Okay, समजला दोघांमधला डिफरन्स सगळ्यांना? डायरेक्टेड ग्राफ आणि अनडायरेक्टेड ग्राफ मधला. Okay. Then next terminology of graph is in degree. Same terminology in tree also. In degree of vertex. In degree of vertex. Okay. In degree of vertex. So I use two examples, directed and undirected. So here my graph is like this: A, B, okay, C, D, A, B, C, D. Here again same example: A, C, D and P. But here in directed graph, direction is there. So A to B direction, D to A direction, A to C direction, C to B direction. Okay. So now in degree states that in directed graph, the in degree of vertex is the number of edges for which it is head. Okay. In directed graph. Means what? C कडे डायरेक्शन कोणत्या एजचे आहे? A to C आहे. बरोबर इथे डायरेक्टेड मध्ये बघा. So in degree of C is 1. Right? A कडे किती डायरेक्शन्स येत आहेत? सिंगल डायरेक्शन येते. सो इन डिग्री ऑफ माय A इज अगेन 1. D कडे 0 बिकॉज D कडे डायरेक्शन कुणाचीच येत नाहीये. अँड हियर B डायरेक्शन फ्रॉम A to B and C to B is there. So in degree of B is 2. But what about undirected graph? This is the example of undirected, right? Undirected. This is my undirected graph, and this one is my directed graph. Okay, this is my directed graph. Okay, A to B, C to D. Okay. So here, in degree of my A is, there is no direction. So calculate how many edges goes from A. So there are 1, 2, 3. So in degree of A is 3. In degree of B is 2. In degree of D is 2. In degree of C is 3. Okay. Okay. In degree समजली सगळ्यांना in degree of vertex. Okay, right, good. Then now next is out degree. Next one is out degree. So here I vanish it and here write down out degree. Okay. Out degree. Now I want to calculate out degree of my graph. Out degree. Okay. So tell me, what about undirected graph? How to calculate out degree? So in degree and out degree is same in undirected graph because there is no direction from any two vertices, right? So same here, whatever the in degree of A, again it is similar, it has out degree. From A, 3 edges are there. So in degree of A is 3, in degree of B is 2, in degree of D is 2, and in degree of C is 3. It is similar to your similar to your in degree. Means in previous example, in degree was 3, B was 2, D was 2, and C was 3. Again in out degree calculation, there is no direction from one vertex to another vertex. So it is similar. So out degree of my A is 3, out degree of my B is 2, D is 2, and C is 3. So here in directed side, directed graph. So in previous example, so here we have to calculate out degree of my vertex, right? Out degree. So here in previous example, what about in degree? How many directions comes to the vertex? We can call it as in degree. Means what? A. There is one direction head. So in degree of A is 1. But it is opposite in out degree. Means what? In out degree, it is the number of edges going out from the vertex. Means how many edges are going? 2 edges, A to B and A to C. So my out degree of my vertex A is 2, right? Because A to B edge is there, A to C edge is there, right? So out degree of my A is 2. Out degree of my A vertex is 2. So what about B? There is no out degree. So it is 0, right? What about D? Out degree is 1, right? What about C? Out degree is 1. Because there is C to B edge is there and D to A direction is there. So D has 1 and C has 1 out degree. But there is no direction or no edge going from B, right? These are incoming edges. A to B and C to B is there. So in degree of B, vertex B is 2, but out degree of my vertex B is 0, right? Okay. So this is my out degree of my graph. Okay. Next example you have to solve. Suppose my example is A, B, C, and D. Okay, A, B, C, and D, and direction is there. A to B, B to C, A to C, B to D, D to C. Okay, and here C has self loop. Okay, now tell me in degree and out degree for the given graph. Tell me the in degree of A, B, C, D and out degree of A, B, C, D vertices. Now calculate and post your answer in chat box. So here I write down in degree for A, B, C and D. Okay, and out degree here, out degree for A, B, C and D. Okay, out degree for A, B, C, D. So now calculate. Okay. ओके, आन्सर आलेले आहेत आपल्याकडे. बाकीच्यांनी पण आन्सर कॅल्क्युलेट करा आणि पोस्ट करा इन डिग्री अँड आउट डिग्री. ओके ओके, आन्सर्स आलेले आहेत आपल्याकडे. आपण बघूया. इन डिग्री मीन्स इनकमिंग एजेस. Here A has one incoming edge, so in degree of A is 1, right? C to A connection is there. What about B? In degree, incoming edges, incoming from A, 1 edge, so 1 degree. C, what about C? So self loop is calculated incoming and outgoing also. So here my C has how many incoming? 1 C to C and 2 C incoming, C to C, B to C, D to C. My C is 3 incoming. Okay. कुणी सांगितले 3C? Okay, प्राजक्ता जगताप, प्रज्वल देवडे. In degree C. Okay, in degree C, Sabha self loop we can calculate it as in degree and out degree also. Okay, so self loop साठी लक्षात ठेवा. and D incoming edge B to D is there, so 1. So what about next here, out degree? How many edges going from vertex A? There is one edge A to B is there, so out degree of A is 1. What about B? There are 2 outgoing directions, B to C, B to D, so B is 2. What about C? Calculate self loop as a 1, so 1 and C to A is there, so 2. And what about D? 1 D to C direction is there, so D is 1. Okay. Okay, so this is the example how to solve in degree and out degree question for my graph. Then next is next some terminologies are there. Suppose my graph contains 3 nodes, V1, V2, V3. Okay, V1, V2, V3. This is undirected graph. V1 to V2 join is there and V2 to V3 link is there, edge is there. So What is the meaning of adjacent vertex? Adjacent vertex. Adjacent vertex. If edge is exist between two vertices, then these two vertices are adjacent. Right? Means what? V1 to V2 connection is there, so we can call that V2 is adjacent to V1. Again, V2 to V3 edge is there, so we can call it as V3 is adjacent to V2. Right? We can change this statement like this. V1 is adjacent to V2. And again, V2 is adjacent to V3 because it is undirected graph. So now next is for direction. Suppose direction is there, V2 to V1, V3 to V2. So now tell me who is adjacent. So now V2 to V1 edge is there for directed. V2 to V1 edge is there, so we can call it as V1 is adjacent to V2. Okay. Again V3 to V2 edge is there, so we can call it as V2 is adjacent to V3. But आपण opposite म्हणू शकत नाहीये because this is directed graph. So this is the terminology of adjacent vertex. Okay, next is predecessor and successor. Okay, predecessor and successor. Predecessor and successor. Next is predecessor and successor. Suppose I have two vertices UV, name as UV. So now here vertex V is reachable from vertex U, right? Because direction states that U is direction is from U to V. So V is reachable from U vertex. So my U vertex is predecessor. U vertex is predecessor, right? Predecessor for V. For V vertex. U is predecessor for V and V is reachable from U to V. So we can call it as V is a successor of vertex U. So this is the next definition, predecessor and successor. Okay. Then next one is relation. Next one is relation. So what is the meaning of relation for graph? Relation. Okay, relation. Suppose my graph is like this. Vertex 1, vertex 2, vertex 4, vertex 3. Okay, 1 to 3 edge is there, then 1 to 2 edge is there, then 1 to 2 to 4 edge is there, and 4 has self loop. Okay, 4 has self loop. Okay, so relation is we can call relation is a connection. Relation is a set of connection. Means what? Collection of edges. Here 1 to 2 connection is there, so this is one relation. 1 to 3 connection is there, so this is second relation. 2 to 4 connection is there, so third relation. 4 to 4 loop is there, so this is again one relation. So we can write down in the form of set. Set is enclosed within curly bracket, and in curly bracket we can put our elements, right? Put our elements. So there are two sets. First set is for vertex. So we can call it as V set. It is enclosed within a curly bracket to 4 vertices, 1, 2, 3, 4, separated with comma, right? And what about relation? Here I use R set for my relation and open curly bracket. So relation we can specify it in angle bracket by using angle bracket. So first angle bracket, 1 to 2 edge is there. This is my relation 1. So 1 comma 2, angle bracket complete. So next is 1 to 3 edge is there. So 1 to 3 relation, second relation, comma. 2 to 4 relation, edge is there. So 2 to 4 third relation. And 4 to 4 means 4 has self loop. So my 4 comma 4 is my next relation, last relation, and relation is complete. So this is called as relation. Okay, relation means similar to your edges, but we can describe our edge set by using round bracket. So one difference is there. We can describe our relation set by using angle bracket. एवढंच फक्त दोघांमध्ये difference आहे. It is similar to your edge set. We can call it as E for edge set and we can call it for relation R. Okay. Next is path. Okay. Next terminology is path. Path. Suppose my 1, 2, 3 and 4. Okay. There are 4 vertices, one name as 1, 2, 3, 4. So path is there. We can read our path like this, similar to your tree. 1 to 2, 1 dash 2 dash 3 dash 4. So we can reach last node by visiting all the nodes. So this is your path. Okay. So next we can represent this path like this because this is undirected graph. So 4, 3, 2, 1. Okay. So this is the path. Length of path. How to calculate length? Length of my path is how many edges are there? Edge 1, edge 2, edge 3. So length of path is 3 because there are 3 edges. So length of path is 3. So next, what about directed graph? What about directed graph? So my directed graph is 1, 2, right? 3, 4. 1, 2, 3, 4. Suppose this one. Okay. 3 to 4, 4 to 1, and 2 to 1. Path. So 2 is not reachable. If I start from 3 to 4 edge is there, 4 to 1 edge is there, but we cannot travel 1 to 2 because there is an opposite direction path, 2 to 1. If I start from 2, what will happen? 2 to 1 edge is there, so here I visited 1, but we cannot reach 3 and 4 because direction is opposite, right? 4 to 1, so we cannot travel 1 to 4 here. So how many paths are there? So first path is path 1. We can reach 2 to 1, so 2 dash 1. This is my path 1. Next path, path 2. This is for directed graph. Remember, I start from 3, then reach 4, then reach 1. This is my path 2. Okay. So there are 2 paths, 2 to 1 and 3, 4, 1. Right? Okay, understood? What is the meaning of path? Okay, here there are two lengths. For path 1, length is 1, right? Because only one edge is there, 2 to 1. Path for second path length is 2, because there are two edges. Okay? Okay, हे समजलंय पाथ म्हणजे काय? Next one is cycle. Next terminology, cycle. Okay, cycle means what? Again, start from one point, again reach this point again, right? बरोबर आहे. म्हणजे पीएमटी आपली सपोज सोर्स अँड डेस्टिनेशन इज सेम, अशा पीएमटी आहेत पुण्यामध्ये, बरोबर? कॉर्पोरेशन टू कॉर्पोरेशन जाणाऱ्या, राईट? स्वारगेट टू पुणे स्टेशन अगेन, the circle. Okay, so cycle specifies that your source vertex and your source and destination vertex is same. Okay, that is called as cycle. Suppose my graph is like this: A, B, C, D. This is undirected. Okay, this is undirected graph. So tell me how many cycles are there? So start from A. So A to B, B to C, again A, right? So this is cycle 1. A dash B dash C. Okay. Then again start from B, B to C, C to D, D to B. So B dash C dash D dash B, right? Here again A, because source and destination is same. Okay, you can write it as for C also, for D also, same way, right? So this is called as cycle. So next is, what about loop? Loop is called it as one cycle again. Suppose my graph is like this, so here I draw one small graph here. Suppose 1, 2, 3, right? 1, 2, 3, 3 to 3, direction. This is directed graph, and 3 has cycle again. Okay, how many cycles are there? Sir, there are 2 cycles from 1 to 3, and again we can reach 1, and second cycle is 3 to 3, because self loop is become one cycle. So in this directed graph 3 cycles are there, right? So cycle is completed. Okay, next is sync node. Sync. Okay, next is sync node. Sync node. Sync node means what? We can call it as, if my vertex has 0 out degree, then this is my sync node. Means what? Sync node is a node such that no edges start from or going out from my given vertex. So suppose this is my graph 1, 2, 3 and 4. How many sync nodes are there? All are sync node. These 4. There are 4 nodes. Sync nodes are total 4 sync nodes are there, because there is no edge. So we can call it as 4 sync node. Suppose I connected 2 to 4, 3 to 4. Okay. Then now tell me how many sync nodes are there? Means out degree 0. How many nodes are there having out degree 0? ओके, आन्सर पोस्ट करा फास्ट. राईट. प्रतीक शिंदे, प्रज्वल देवडे, ओंकार. ओके, या तिघांचे आन्सर करेक्ट आले बिकॉज देर आर 4 nodes, but 2 has out degree 1 because 2 to 4 age is there. 3 has out degree 1 because 3 to 4 is age is there. But what about 1 and 4? 1 तर दिसते, 1 कडून एज जात नाहीये. सो सिंक नोड, टोटल सिंक नोड, पहिली सिंक नोड मला मिळाली 1. Then what about 4? 4 has again out degree 0. So there are 2 sync nodes, 1 and 4. Answer is there are 2 sync nodes. कारण 4 पासून पण एज जाते का कुठे? नो. तर 4 ला सुद्धा कन्सिडर करायचे. ओके, दिस इज स्मॉल मिस्टेक. अशा मिस्टेक आपल्या एक्झाम मध्ये होतात ग्राफ आणि ट्रीच्या एक्झाम्पल मध्ये. तर ते नीट बघायचं आणि नीट बघितल्यानंतर ठरवायचं की काय आहे. ओके, तुम्हाला सिंक नोड कळलं, पण आन्सर देताना तुम्ही फक्त 1 कडेच लक्ष केलं, पण 4 पण आहे सिंक नोड. कारण 4 कडून पण कुठे डायरेक्शन एजेस गेलेली नाहीये. राईट. सो सिंक नोड, वी कॅन कॉल इट एज सिंक नोड बिकॉज देर इज नो आउटगोइंग एज फ्रॉम नोड. ओके, नेक्स्ट टर्मिनॉलॉजी आर्टिकुलेशन पॉइंट. नेक्स्ट इज आर्टिकुलेशन. Articulation point. Articulation point, or we can call it as again, or we can call it as cut vertices. Cut vertices. Okay, cut vertices. Okay. My first example, cut vertices 1, 0, 3, 2, 4. Articulation point or cut vertices are exist in only undirected graph. Okay, 1 to 2, 0 to 2, 3 to 4. So articulation points means what? If I cut one vertex from my graph, or I remove one vertex from my graph, any vertex, okay? If it disconnects my graph into parts, 3 parts, so we can call it as articulation point or cut vertices. So आता जो इथे ग्राफ दिलेला आहे त्याच्यामधून असा एक वर्टेक्स बाजूला जर काढला तर माझा ग्राफ 2 ग्राफ मध्ये डिवाइड होईल, 3 ग्राफ मध्ये होईल जर मी तो वर्टेक्स रिमूव्ह केला तर बघा इथे नीट लक्ष द्या. सपोज मी 0 ला रिमूव्ह केलं म्हणजे ही एज काढली, ही एज काढली, ही एज काढली. बघा ग्राफ 2 ग्राफ मध्ये डिवाइड झालेला आहे. 1 to 2 एज आहे, 3 to 4 एज आहे 0 ला काढल्यानंतर. ओके, कन्सिडर करा इथे 0 नाही आता. ओके, सो 0 इज माय आर्टिकुलेशन वर्टेक्स. सो वर्टेक्स 0 is my articulation point or cut vertex. ओके, दुसऱ्या एखाद्या वर्टेक्सला बघा जर मी 3 ला रिमूव्ह केलं तर काय होतंय? 3 ला रिमूव्ह केल्यानंतर हा डायरेक्ट फ्री होतोय नोड, त्याचा मग काहीच यूज नाहीये. आणि इकडे एक सिंगल ग्राफ राहतोय, 2 ग्राफ मध्ये डिवाइड होत नाहीये. तो मिनिमम 2 ग्राफ मध्ये डिवाइड झाला पाहिजे. ओके, ओके, बट 3 ला मी रिमूव्ह केल्यानंतर 4 राहतोय. लास्ट टाइम मला कोणी सांगितलं 4 we can call single vertex as one graph. So again 3 is my articulation point, vertex 0 and 3. Okay, 0 and 3, right? So previous images. Okay, this is my previous image. Okay. Why articulation point 0? Because if I remove 0 from the graph, it is divided into two graphs. Like first graph contains 2 nodes, second graph contains 2 nodes. That is my second graph. So first articulation point or cut vertex is 0. Then next, okay, याच इमेज मध्ये बघूया. सपोज मी 2 ला रिमूव्ह केलं इथून. ओके, 2 ला रिमूव्ह केलं इथून, तर काय होतंय, हा कनेक्टेड ग्राफ राहते 1 2 0 0 3 4. सो 2 इज नॉट आर्टिकुलेशन पॉइंट, राइट. 4 ला रिमूव्ह केलं तरी ग्राफ डिवाइड होतोय का? नाही. कनेक्शन राहते, ग्राफ तसाच राहतोय, डिवाइड होत नाहीये. त्यामुळे 2 आणि 4 गेले. व्हॉट अबाउट 1? इफ आय रिमूव्ह 1 फ्रॉम द ग्राफ, so 2 to 0 0 to 3 3 to 4, all nodes are reachable remaining. So this is again not articulation point, right? Okay, what about 3? If I remove 3, then this is my one graph having 3 nodes and this is my second graph having 2 nodes. So there are 2 articulation points. First one is 0, second one is 3. Okay, 2 articulation point. Next example. Tell me how many articulation points in my next graph. Suppose my graph is 1 2 3 4 5 6 7. A, B, C, D, E, F, G. Tell me how many articulation points are there, or which is articulation or cut vertex from this graph? Which is? Right, one answer, Pratik Shinde. If I remove C, so my graph is divided into 3 subgraphs, right? This is my graph 1, A to B. This is my graph 2, single vertex, D. This is my graph 3, G, F, E. So if I cut C from the graph, so it is divided into 3 graphs. So C is my articulation point. Again, दूसरा कोणता आहे का articulation point? Check करा. Tell me, is there any exist articulation point other than C vertex? आहे का? No. बघा ना, A remove करा, B, C, D, E, G are connected. If I remove B, A, C, D, G, E, F are connected. If I remove E, all nodes are connected. If I remove G, all nodes are connected. So there is only single articulation point in my graph, that is C. बरोबर. ज्यांनी no सांगितलं, answer is correct. Then tell me next graph. Suppose my graph is there like this. 1 2 3 4. 1 2 3 4. Connected, 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 connected. Okay, tell me which is articulation point. Tell me now how many articulation points are there, or which is articulation or cut vertex. 3. If I remove 3, no, connection is there. 1 to 2, 2 to 4 is connected. No, 3 is not articulation point. Right, Saurabh Rajput given answer. There is no articulation point. There is no articulation point. बघा तुम्ही कोणताही node remove करा, graph is connected. If I remove 2, 1, 4, 3 connected. If I remove 1, 2, 3, 4 connected. Right? If I remove 4, 1, 2, 3 connection is there. So it has no articulation point. No. 4 मी काढून टाकला प्रोजेक्ट तरी पण 1, 2, 3 connected आहे. Graph तसाच राहतो. So this type of graph has no articulation point. Okay. So now next example, if I remove some edges from my given graph. Okay. So now tell me, is there any articulation points or how many articulation points for this graph? One, two, three, 4. Right. Prasad, Rohit, Samiksha, Pratik, Vinesh. Right. Right. If I remove 2, so graph is divided into 2 subgraphs. This is my graph 1, this is my graph 2. If I remove 3, graph is divided into 2 subgraphs. Graph 1 contains 1, 2, graph 2 contains 4. So there are 2 articulation points and these are 2 and 3. Okay, 2 and 3. So now next, the last part, adjacency list and adjacency matrix. Adjacency list and adjacency matrix. Okay. So first is adjacency list. Adjacency list. Okay, this is important topic according to your exam. 100% one question is there in your end semester exam. Show adjacency list or show adjacency matrix for given graph. 2 or 4 marks question is there. Explain adjacency list and adjacency matrix with example. This is very important topic. Okay, very and it is very easy. Okay, adjacency list means what? Suppose there are 2 examples. Okay, this is my undirected graph 1, 2, 3 and 4. 1, 2, 3 and 4. Again 2 and 4, 4 and 3 connected. Suppose the second example of my adjacency list is second example 1, 2 and 3. But here 2 to 3 edge is there, 1 to 2 edge and 2 to 1 edge. This is directed graph. Okay. Adjacency list means what? Every vertex is termed as head node, and if there is a connection between one vertex to another, then we can add it in the linked list. Linked list means what? There is a node structure which is connected together. Okay. So adjacency list is termed as each list has a head node. The head nodes are sequential, providing easy random access to the adjacency list for any particular vertex. Okay. So tell me for this graph, V set, vertex set 1, 2, 3, 4, right? Here for this graph, vertex set V is equal to 1, 2, 3. Right? Age, set of ages. Here, ages 1, 2. Again 2, 4. Again 4, 3. Next 1, 4. Next 1, 3. Complete. Okay. We can describe it as opposite direction 2, 1, 4, 2, 3, 4, 4, 1, 3, 1 because it is undirected. What about directed? Age set E is equal to 1, 2, right? 2, 1, right? 2, 3. No age going from 3. So our degree of third vertex is 0. Right? So this is age set. So how to represent adjacency list? By using linked list. So create linked list for each and every vertex. So this is my linked list for vertex 1. This is my red node. How many nodes are there? 4 nodes. So this is my linked list for 2. This is my linked list for third vertex. And this is my linked list for fourth vertex. Okay. So now connect it together. From one vertex, we can reach how many nodes? 1 to 2, 1 to 4, 1 to 3. So write down it as 2, right? 4 and 3. So this is my adjacency list. Close. Okay. We can write it as again 2, 4, 3, 3, 4, 2, 4, 2, 3, 2, 4, 3. Any sequence. Because our starting point is same 1. 1 to 2, 1 to 4, 1 to 3 age is there. Means you can change the sequence from 2 to 4, 3. Okay, next is from 2, head node is 2. How many edges? 2 to 4 connection is there, 2 to 1 connection is there. So here 1 and then next one is 4. Right? 4 is last. Then what about 3? 2 nodes are two vertices are connected 1 and 4. So here write down is 1 and 4. You can write 4 first, 1 last. No problem. What about 4? 2, 3, 1 connected, right? So 2, next node 3, next node 1. Okay, next node 1. End. So go here. What about directed graph? How many linked lists? 3 linked lists because 3 edges. This linked list for one head node. This linked list for second vertex. This linked list for third vertex. Okay. 1 to 2 connection is there. 1 to 2 connection is there. So 1 is connected to second vertex. So second node is connected to 2 vertices. 1 and 3. Right? 1 and 3. And third, next, this is last. Right? What about 3? There is no outgoing edge from 3, so this is single node. So it is your adjacency list. Okay? It is your adjacency list. Okay, got it? Adjacency list. Okay, next is adjacency matrix. Adjacency matrix. Last point of this unit and syllabus. Adjacency matrix. Adjacency matrix. Okay, adjacency matrix. Suppose my graph is like this: 1, 2, 3, 4, 5. Same graph for directed. Here I written 1, 2, 3, 4, 5. Okay. Here direction is there. 1 to 2, 1 to 4, 4 to 5, 5 to 3, 2 to 5 to 5, 5 to 2, and 2 to 3. Okay, adjacency matrix. The adjacency matrix of a graph is two-dimensional array, okay, of n cross n elements where n is the number of vertices. Okay, n cross n means how many rows and columns? N. Means what here? 5 vertex. So in my adjacency matrix, 5 rows, 5 columns are there. Here for directed graph, 5 vertices are there. So my adjacency matrix contains 5 rows, 5 columns. Okay. Total number of vertices, it becomes your column value and row value. Okay. Okay, there is one rule. If my graph of first vertex, suppose I called it as I, and second vertex I called it as J. If there is an edge, so I put one value for that. Means what? 1 to 1 is node is connected to second node. So I set value for this edge is 1. If there is no edge between I to J vertex, so we can put 0 for that. Okay? It is very simple. So my matrix name is G, my matrix name is G. Okay? Equal to matrix, so square bracket, matrix, square bracket. Okay. How many rows, how many columns? 5 rows, 5 columns. Okay. So here my column names are my vertices, that is 1, 2, 3, 4, 5. My rows numbers are becomes my vertex number 1, 2, 3, 4, 5. Similar here. Column number 1, column number 2, 3, 4, 5 for 5 vertices. Row number 1, row number 2, row number 3, 4 and 5. Okay. Okay, 5. So put 0 and 1 for that. So how to read? Read it as, read your row number and then column number. So 1, 1. 1, 1 connection is there, no self loop, so put 0. Right. So start from row 1, 2 connection is there, 1, 2 connection is there, so put 1. 1, 3 connection is there, 1, 3 no connection, no edge, so put 0. 1, 4 edge is there, so 1. 1, 5 no edge, so 0. Okay, it is very easy. Then next, second vertex, vertex 2, row number 2, second vertex, 2 to 1. 2 to 1 is connection, yes, so put 1. 2 to 2, no self loop, 0. 2 to 3, edges exist, so 1. 2 to 4, no edge, so 0. 2 to 5, edge is there, so 1. For third vertex having edges, 3 to 2, 3 to 5, so it becomes 1, 1. 3 to 2, so put 1 here. 3 to 5, put 1 here. Remaining are 0, 0, 0. What about 4? 1 and 5 are connected, so put 1 for 1 and 5 for 1. Both remaining are 0. What about 5? 2, 3, 4 connected, So put 1 for that. 2, 3, 2, 3, 2, 3, 4 connected. So 5 to 5, 0, 5 to 1, 0. Okay, this is my adjacency matrix. Come here for directed graph. Check 1 to 2 connection is there, 1 to 4 connection is there. So 1 to 2, 1, 1 to 4, 1. Remainings are 0. Okay? Read from row, not from column. आता 2, second vertex कडून outgoing edge कुठे आहे? 3 कडे आहे. So 2 to 3 is 1. Remainings are 0. So put 0. Then 3. There is no outgoing edge for 3. So all are 0. Right? All are 0. Then next 4. 4 to 5 edge is there, so here 1 and others are 0. 5 to 2, so 5 to 2 here, and then 5 to 2 and 5 to 3. So 5 to 3, 1, remainings are 0. Okay. So this is your adjacency matrix. Okay. This is your adjacency matrix. Okay. Last example. Suppose my graph is here. Okay, I draw one graph. 1, 7, 12, 19, 21, 31, and 14. 14 has same Q. Same Q. 1 to 7 connection. 1 to 12 connection. 12 to 19 connection. 12 to 19 connection. Then 19 to 1 connection. Then 1 to 21 connection. Then 7 to 21 connection. Then 31 connected. Then 14 connected. 19 to 21 connection. Okay. And again, there is single node 67. Okay. Okay, consider this graph and tell me the answer. Okay. Okay, first सांगायचंय मला in degree of 21. Okay, tell me in degree of 21. In degree of 21. Ka in degree? In degree of 21. Right, 3, because 21 incoming edges, 7 to 21, 1 to 21, and 19 to 21. Right. So in degree of 21 is 3. Okay. Then tell me adjacent node for 19 number vertex. Tell me which is adjacent for 19. Adjacent node for 19. Post your answer first. Adjacent means from 19 we can reach how many nodes? From 19. So 19 to 1 vertex there is an edge. 19 to 1 and 19 to 21. So adjacent nodes are 1 and 21 is correct. Okay, 1 and 21. These are adjacent. Tell me successor of 67. Successor of 67. Which is successor of 67? No, because it is single node, so no successor is correct, right? दिलेले answer खूप जणांनी no successor. Okay, no successor. Tell me sync nodes from the graph. Sync node. Tell me the name of sync node. Post your answer fast. Sync node. Sync node. Okay, some answers. Okay. Right. Answer is 67 out degree 0, 31 out degree 0. So my sync nodes are 67 and 31. 67 and 31. Right. Then tell me path. Tell me the how to reach 31. Path for 31. Path for 31. Okay, path for 31. Consider starting point is 1. Okay, this is my starting point. Vertex 1. Starting point is 1. Okay, one path posted some students 1, 21 and 31. 1 dash 21 dash 31. Okay. Is there any path exist? Another path? Yes, right. Vinesh posted 1, 7, 21 and 31. Again, another path is there. Another. Right. Rohit posted 1, 12, 19, 21 and 31. So how many paths are there to reach 31? There are 3 paths. Right, 3 paths to reach 31. Tell me articulation points. Articulation points. Which is articulation point? AP or cut vertex CV. Tell me. Articulation point. Yes, Saurabh Pote posted 21 is articulation point, right? Because it is divided into again 31 and 14 not reachable. So 21. Another. Any another? Only 21 or any other vertex is again articulation point. (19). If I remove 19, what will happen? No any single vertex is free. 19 ला रिमूव्ह केल्यानंतर कोणता वर्टेक्स फ्री होतोय का? नाही होत, कारण 1 to 12 कनेक्शन राहते, 1 to 21 पण कनेक्शन राहते. So 19 is not articulation point. Right, graph remains connected after removing 19. So 19 is not. So there, I think there is only single articulation point, that is 21. Right? 21 is my articulation point. Right, only 21 node is articulation point. Okay, it is very easy. Okay, post cycles exist in my graph? Cycles means first and last, source and destination is same. How many cycles are there? Cycle किती सायकल्स आहेत? चला पहिली सायकल मिळाली 14-14. This is self loop considered as one cycle 14-14. 1-12-19-1. Okay, Saurabh Rajput 1-12-19-1. Okay, this is cycle again, second cycle 1-12-19-1. Next cycle. Next another cycle is there. We can term it as 19-1-12-19 again, right? Because 19-19 we can reach 19 from visiting 19 to 1, 1 to 12, and 12 to 19. So 19-12-1. Sorry, 19-1-12-19, right? Again for 12, again we can represent it as 12-19-1-12. Barabar? For all nodes from one cycle. So 12-19-1-12. Okay. So skip this. Tell me another cycles. Only 4 cycles are there. Okay. 1, 2, 3, 4. Right. Again, no cycle is there. Okay. Cycles completed. Okay. Tell me out degree for 19. Out degree for 19. Out degree for 19. Out degree for 19. Out degree. Right. Pratik Shinde posted 2 is out degree for 19. Right. We can reach 19 to 1, 19 to 20. So 2 is out degree. Okay. Take screenshot for that. So here we completed our whole syllabus from 1 to 5 units. ओके. सिलेबस सगळा कंप्लीट झालाय. नोट्स शेअर केलेले आहेत. ओके. बाकीचे जे राहिलेले प्रॅक्टिकलचे व्हिडिओ मी शेअर करेल तुम्हाला. ते कन्सिडर करायचे आणि ते सुद्धा कंप्लीट करून तयारीला लागायचंय. नेक्स्ट वीक पर्यंत सबमिशन कंप्लीट करायचंय. ओके. याच्यामध्ये कुणाला काही विचारायचंय का अजून?